Introduction to Lean Thinking. Today's first webinar is titled Value for the Customer, Identify Your Value Stream. I'm Dave Desker, Vice President of Marketing at AME Canada, and I'll be your moderator. Today's presenter is Richard Evans, the President of JR Lean, VP Programs East, Vice President Programs East for AME Canada, Chair of the Lean Certification Oversight and Appeals Committee, and a Training Within Industry Certified JI and JR Instructor. Richard has spent the past 4 decades helping companies become more effective in delivering quality and value to the production process while focusing on customer success. Having a manufacturing engineering background, Richard helps organizations to recognize waste through mentoring, coaching, and applying lean principles, tools, and techniques. His extended knowledge of various industries, including automotive, aerospace, railroad, packaging, food processing, printing, and fasteners, have enabled him to quickly focus in on opportunities for improvement. During the past 10 years, he has assisted companies in developing lean transformations and has facilitated over 50 Kaizen events. Before we start, let's just get a couple of housekeeping items. You'll be in a listen mode only throughout the webinar. You'll see that you're muted on your attendee panel on the right side of your screen. If you have any questions during the webinar, please type them into your question area in the attendee panel and click on Submit. We'll review the questions at the end of today's presentation and answer as many as we can. When you log off today, please check your email inbox. In it will be an invitation and a link to fill out a short webinar attendee survey. Please take a few minutes to complete the survey today, as your feedback is very important to us to improve future webinars. Richard has also graciously agreed to provide a PDF of today's presentation. We'll be sending that along with a recorded link from the webinar today, early next week. Now I'm pleased to present Richard Evans, who will present Value for the Customer, Identify Your Value Stream. Take it away, Richard.
Thank you, David. Good afternoon, everyone, on the Eastern time frame and Central time frame, and good morning to everyone who's on Mountain Time or Pacific Time. So today we're going to look at the 5 principles of lean. This is the first session in a 4-part session where we look at how you want to make value flow through your organization. And we're going to be following the 5 principles of lean as depicted by James Womack in his Lean Thinking book, which many of you may have read already. Our part 1 today, as Dave mentioned, is value for the customer and identify the value stream. And before we get into the session, I'd like to ask all of you a question. A simple question, because you've all got the same goal, and your goal is to improve your business. So if you want to improve your business, there's 2 things you must know. So let's think about that. You want to improve your business, there's 2 things that you must know. The first thing is to define value in the eyes of your customer. This is a really interesting statement because many times I sit with groups, I sit with individuals, and I ask them, you know, why are you here today? And we get a lot of responses. Oh, I've been voluntold. I'm here to learn. I want to know about lean, etc. And really, the only reason that they're with me is because they get paid. If they didn't get paid by their organization, they'd be somewhere else looking for a way to get paid. Because unfortunately, in this life, money is the source of everything. And that's why people go to work. So I ask them very simply, how does your organization pay you? What do they do in order to earn money? And the response is we make parts or we provide a service. And I'll say, okay, so that's the only way that you make any money? And they go, yes. And I say, do you realize that there's only two types of people then that work in an organization? The people who add value to the product or service that you sell, that pays your wages and puts food on your table, and then the people who support the people that add the value to the product or service that pays your wages and puts food on your table. So your focus of everyone is to make that value flow through your business with the least resistance. So the people who support the people who add the value, their goal in life is to make the work and the job of those value adders as easy as possible, because they're the ones that pay your wages. So if you want to improve your business, you've got to be able to define what value is in the eyes of your customer. That's the first thing you need to know. So what do you think the second thing is? Well, the second thing is that you should be able to recognize when you're adding value. Because if you're not adding value, you're really not doing anything to earn money. So being able to recognize at any moment in time when you're adding value, it can tell you that the rest of the time you're just actually incurring waste. And fundamentally, this is what lean is all about. It's being able to see the waste within your process, within your organization, and then by whatever means that you deem fit, to eliminate it. So remember these two things before you embark on anything. What's the value, and how do you know when you're adding value? So how do we define lean or continuous improvement? Well, if you're not familiar with the term lean, you might have a vision in your mind, oh, it's a piece of beef with no fat. That's lean. And when we go and buy ground beef, if we're a lover of spaghetti or shepherd's pie or something like that, we see lean ground beef, and then we see extra lean ground beef. So obviously there's some levels of whether you're lean or not. But in essence, lean is really the elimination of waste throughout your process. So here's a statement that you might want to embrace. Continuous improvement or lean, what are we doing? We're continuously eliminating waste so that every step adds value for our customers. Because guess what? It's your customers that actually put food on your table. So there's a few things here we want to look at. The first, obviously, is this word continuously. Continuously here tells us that we really want to do it all the while. And then we have this other one, every step. What do we mean by every step? Well, obviously, whenever you receive an order from a customer, there's multiple steps in providing them with the finished product or the service that you're going to provide them. So every single one of those steps, you should strive so that it's adding value. And really, it's an impossibility. You're never going to achieve 100% value added because, as you'll see as we go on in this session, there's a lot of waste within the things that we do. So let's move on. What do we perceive as value? Well, your customers, yourselves, when you go and shop for things. And when we go and shop for anything, the first thing we might want to look at is it available? Is this thing available that we want? So maybe on-time delivery might be something that is considered value by any customer. We look at other things, maybe things like, is it good? Does it do what we want? Okay, is it going to give us everything we need? And we can say that quality is a value because it's the second thing that a customer sees. And then thirdly, we're probably going to say, well, I don't want to pay too much money for it, so reasonable cost is maybe the third thing a customer thinks about. So this recognition of value we call it QCD, quality cost delivery. That's really what our external customer focuses on, and that's what they want. But how about your internal customers? And some of you might say, what do you mean by an internal customer? If you're providing something to somebody further along in the process, then they're your customers. What do you think they value? When was the last time that you walked, we use the term downstream, to ask your customer, your internal customer, if there was one thing that I could do better, what would it be? Well, I'm sure they would agree with you that they pretty much want the same as your external customers. I want it 100% on time, and I want it 100% right. 100% on time, 100% right. Probably don't think too much about the cost, being an internal customer. But value is no different from the external to the internal. So how do we know if we're adding value at any moment in time? If you walked into your plant or your office where you work and you pointed at a product, or if you're a serviceman, you looked at what that service person was doing, how would you recognize if value was being added to that product or service? In 1 second, 2 seconds, 3 seconds? Now let's have a look. So we can say that value is any action that changes the shape, how it goes together, or how it works of any product or service in line with customer requirements. So value is any action that changes the form, which is what it looks like, the fit, how it goes together, or function, how it works, of any product or service in line with customer requirements. So, if you look at what we call the 3 divisions of work, if you make a product or provide a service, then it obviously takes time to make that product or provide that service. And we call the time lead time. So from the start of the clock when you receive an order to when the clock finishes and you've provided that good or service, the time in between is called your lead time. And it's comprised of 3 elements that are associated with value. So the first of those elements is what we call value added. So any process that changes the nature, shape, or characteristics of the product in line with customer requirements, i.e. assembly, machining, you want to maximize that as much as possible. Because you're changing the shape, you're changing the nature of it in line with what the customer needs. So you're adding value. So then we have what we call non-value added but necessary. So non-value added but necessary is any work that is necessary under current conditions, but it doesn't increase any product value whatsoever. For example, inspection. I ask a lot of people, why do we inspect things? And the main answer that is given back, to make sure the customer gets what he wants. And I say, is that the real reason that you inspect things? And they think about it and they say, yeah. And then I ask them, okay, so if you drive to work every day, do you inspect the tire pressure on your tires? And you can tell how old I am because this was before we had little icons on our dash that told us when the tires were low. But we really didn't inspect the tire pressure every time we get in the car. And think about why we don't. And the reason really is because we trust the process. We trust the process of filling the tire with air and it seals on the rim. And we know from data, from experience, that it's pretty good. So we don't inspect it. So the real reason that we inspect anything is because we don't trust the process that created it. It's not robust. It's less than 100% productive and effective when it does its job. Another non-value added but necessary element is moving parts. So you move parts between one machine and another. You actually pick them up from the floor on a batch. You might put them in a machine or work on it. And the picking up and the putting down is non-value added. It's only when you're changing the shape that you're adding value. So you want to try and minimize these as much as possible. Tool changing, maintenance, again, is non-value added but necessary under current conditions. And once you've exhausted all those items, that leaves us with the third division, which is pure waste. So all other non-essential activities, the 7 W's, the 7 deadly wastes. Interesting. So if you look at the 3 divisions of work, and if we were to say we're going to have a pie with 3 slices, how big a slice do you think for a traditional non-lean manufacturing organization, how do you think the value-added slice would look? How do you think the non-value-added slice would look? How do you think the waste slice would look? I get a lot of people saying, oh, the value-added 50, 60, 70%. And I'll say, so for 60% of the time it takes you to make your product, you're adding value? And they go, yep. I say, are you making one at a time, or are you making things in batches? Majority of the time they respond, oh, we make in batches. Okay, so you've got a batch of 10, say, and you're working on one piece. What's happening to the other 9? And then their eyes wide open, and a little light bulb comes on, and they said they're sitting there waiting. And I go, oh, they're waiting. Okay, so let's say we've finished that one piece, and it's now ready to move on to the next process. And you pick up another one. What happens to that one piece? Can it move on? And they say, nope, it's got to wait for the other 9 to be finished. Wow. So every time you make one and you're adding value, the other 9 are just sitting there having a nice rest, gathering dust, and just waiting. So then they start to think about the size of these pies. And in a traditional non-lean manufacturing organization, this is about what the slices of the pie look like. So for 5% of your lead time, you're adding value. For 95%, you're not. So if lean is all about eliminating the blue and the red, and if you're colorblind, the 40% and the 55% slices, if that's what lean is all about, if you made those slices smaller and the 5% one bigger, would you be improving your business? And the answer is yes. So this takes me back a number of years ago in Canada, where I'm located. The Canadian Manufacturers and Exporters Association, they got a lot of members, and they put out a 2020 survey. And one of the questions to, I believe, over 500 companies was, are you, or do you have any intent of doing lean over the next 5 years? And 65% responded no. And it didn't really surprise me, but it told me one thing. It doesn't tell me that they didn't want to do lean. It told me that they had no clue what lean was. If we'd have changed the question and said, are you or do you have any intent of improving your business over the next 5 years, I'll guarantee 100% would have said yes. But they didn't associate improving their business with lean. And lean's just a mindset of getting rid of that waste so that we can improve the flow of value through your organization. So let's go to a poll question. Let's see if everybody's been paying attention. So I've got poll question number 1. Which of the following is considered value-added work? Is it A, eliminating all defects and the need for rework? Is it B, empowering employees to establish their own work standards? C, activities that must be performed under present work conditions? Or D, changing the shape or character of a product or service? Dave, can you post the poll question for the audience, please? So I'm going to give you about 20 seconds. So is it A, B, C, or D? Which of the following is considered value-added work? Is it A? Is it B? Is it C? Or is it D? Okay, Dave, let's go back to the question. So let's have a look at the answer. So the answer is D, changing the shape or character of a product or service. Let's see how the audience did, Dave. Let's do the results. Wow, looks really good. So everybody's awake. This is cool. Thank you, Dave. Thank you so much. So that was good. Obviously, changing the shape or character is considered value-added work. So now, in order to maximize the value for your customer, how do we approach continuous improvement? What is it you think we need to do, and in what sequence, in order to get rid of this waste? So I've always focused on what we call the 5 principles of lean thinking. And we're going to go through them today, one at a time, and I'm going to show you why. So the first principle is to define value from the customer perspective. We've talked about value. We know it's QCD, quality cost delivery. And they should be your prime metrics along with safety that you measure every single day. And we understand that we don't add value all the time. So if we're not adding value, we must be incurring waste. So how do we recognize waste? So let's have a look at what we call the 7 forms of waste. So the first waste is the waste of transportation. So that's excessive movement of people, information, or materials. So if we transport goods, either in raw material, work in process, finished goods, are we changing the shape of anything? Are we adding any value to it? And the simple answer is no, we're not. Is it a necessary evil? Yes, because unfortunately we have not got a transporter on Star Trek yet. That'd be so cool if we did. We could probably eliminate a lot of transportation around the planet. But right now, excessive movement of people, information, or materials is a... This is an organization up in Canada, and you can see the traffic flows of the products, and they're multicolored, and it shows where they go. And they did an analysis, and they found that the products moved a total of about 2 kilometers, or about 1.6 miles, in moving around this particular area. And they said, what a waste. How can we reduce the transportation? So they rearranged the area and minimized it tremendously. They took about 80% out, and they got down to around about 300 or 400 yards. Still transporting stuff, but the material movement was reduced quite considerably. And you didn't do it overnight. They probably came together and they ran what we call a Kaizen, which is spelled Kaizen, which essentially means continuous improvement, but in the purest terms, it means good change. Kai meaning change, Zen meaning good. So whenever you make a good change, whether it be a very minuscule one or a bigger one such as this, you've actually done Kaizen, which is continuous improvement. So we say, let's go Kaizen. Let's get everybody to do a Kaizen every single day. So we reduce some of the transportation. The second form of waste is inventory that's unnecessary, because there's good inventory and there's bad inventory. So the unnecessary inventory is excessive storage and delay of information or products. Hey, we can justify the new warehouse. We're running out of room. Reduce your inventory because you're not adding any value with it sitting on your shelf, with it being either work in process or raw material or even finished goods. So same in the office as well. You're carrying lots and lots of unnecessary inventory. And probably if you look even on your hard drives, on your computer, on your network, how much information have you got stored there that is totally, totally unnecessary? We think a lot about organizing physical things, but we think less about organizing electronic stuff. And people are using electronic information much more nowadays than we ever used to. And surely knowing where it is and being able to access it very, very, very quickly is key. Otherwise, you're not adding value. So unnecessary inventory is a waste. So those are the first two. The third one is motion that doesn't add value. Motion that doesn't add value. You've got a really nice factory here, but the distances between certain processes, it looks a long way. So you've got a lot of motion is going on in there. Looks like they're not in any cell format, but they look really good. But I wonder how far the products move between them. I don't know. It's just a picture I found. And I've looked everywhere. We've lost the projector again. How about that? Who's got the projector? Oh, it's not signed out. What do you mean signed out? We don't have a sign-out system. Oh, well, who's got it? I'm not sure. Joanne was asking for it yesterday. Maybe she's got it. Let me phone her. Oh, I'll send her a text. But unnecessary motion, looking for stuff, not being able to find it, needing a tool to do a changeover, which is non-value added anyway, and that tool is locked in the tool crib because it happens to cost $350, and they don't trust it being left out in the shop. Total waste, and you probably find that $250 is gobbled up within the first day of people wasting time going to fetch it. So any motion, you're obviously not adding any value to anything unless you're assembling something. In that case, you might be, unless you're hand filing something that requires hand things, or unless you're machining something, and then that's motion that does, obviously. The fourth form of waste is what we call waiting. And that's everybody. Everyone is waiting for stuff, parts, machinery, people, information, materials, long periods of inactivity. It's a total waste. The example that I gave you earlier, when you're making batches, you know, if you make any more than a batch of one, and then the other poor one is waiting while that one is being worked on. So obviously the more larger your batches are, the more parts are waiting all the while. If you work in a manufacturing area, just have a walk around on the floor, and we call it the gemba. the place where the action takes place, just go to the Gemba and then see how many bits are actually sitting on the floor and how many bits are actually being worked on. And it's quite interesting. You know, I go in some companies and say, how many single parts have you got on the floor right now? And they go, well, we've got about 400 work orders. We've got about 10 in each batch. So 4,000 bits. Okay. How many machines you got? How many spindles? Oh, we've got 30. Okay. How many am I actually running right now? About 8. Okay, so 8 pieces out of 4,000 are having value added to them. All the rest are waiting. Same in the office as well. It's amazing how much time we wait for stuff, working on support, administration, and things like that. There's a bit of information we haven't got. So what do? Send an email, send a text, and you got to wait for a reply. Make a phone call, nobody answers, leave a message, then you got to wait. Huge amount of waiting that's going on within all our organizations. So it's recognized as one of the 7 deadly wastes. So that takes us to poll question number 2. If you have a look at this one, walking to retrieve a tool to perform a changeover is considered what form of waste? Is it A, transportation, B, motion, C, unnecessary inventory, or D, waiting? Dave, can you bring up poll question number 2, please? So, 20 seconds to answer this one. Is it A? Is it B? Is it C? Or is it D? We're walking to retrieve a tool. So 20 seconds is up. Let's have a look what the answer is. So the answer is motion. So let's see how the audience did with their results. What's the percentage, Dave? I can't see it.
Richard, we've got B, motion, 93%, and D, waiting, 7%.
Okay. Well, obviously, thanks, Dave. You can close that one off. The machine is going to be waiting. That's so true. So you've got a little bit of both of those wastes in there, and you've really got a little bit of transportation as well, because you're going to retrieve a tool and then you're going to transport it, and there's the walking, the motion, and then the changeover is waiting as well. So it's easy to see why somebody might have misconstrued that one. But it's a form of waste. As long as you recognize it, that's really cool. So let's have a look at the next form of waste. Overproduction. This is an interesting one. Overproduction, producing more or sooner than the internal or external customer needs. Cheer up, we can always have another sale. And guess what we do? All of the models from 2016 are going on sale because they want to get room for the 2017 models to come in. But it's interesting when we say overproducing, we always think it's producing more. And we don't usually consider that making things sooner than the internal or external customer needs them is overproduction. But sooner is just as bad as making more. I'll give you an example. You've got a machine that probably takes maybe 1 to 2 hours to change over from one operation to another on a different part. And this particular one was really tricky. It took him 2 hours to get the first piece correct. And he's running a batch of 10, and the cycle time's 4 hours. And he's getting close to the last one, and he happens to see in his queue that 4 jobs down on his queue is exactly the same job, exactly the same operation. And he thinks, I'm going to do that next. It'll save me 2 hours on changeover. And he decides to do it, and the first batch goes off on its merry way, and he puts the next part on. And then consider what happens to all the rest of the other 3 jobs that are waiting ahead of that one. Then they're going to wait 10 times 4 hours. 40 hours, you're going to delay the flow of your product through the factory for saving 2 hours. And then you might have equipment that's downstream, further on in the process, that's waiting for job number 2 and waiting for job number 3. So producing sooner has some dire consequences. And we really do not want to run the machine just to keep it running and to get utilization, because utilization is an anti-lean measurement. It's a terrible measurement. And accountants love it because they think it pays their equipment off faster. But they're not looking at the true cost of the product. So overproduction, I printed double so everyone can read it twice. Okay, you can print copies of the handouts, and then people look at it on the screen, and 95% of them never open their copy of their handout. So that's really overproduction as well. And of all the wastes, the very worst waste of all is in fact overproduction, because it drives all the other wastes. And when I get to the end of the 7 wastes, I'll explain why. So that's number 5. Number 6 is what we call overprocessing. Using the wrong set of tools, procedures, or systems. Using the wrong set of tools, procedures, or systems. How can we explain overprocessing? Well, we might be scheduling equipment using MRP. Just had a heart attack. You might be scheduling it using a work to list. That's overprocessing, because MRP is only as good as all the information that's being fed into it, and it's really dumb. It doesn't know what reality is. It doesn't know that the next downstream process has finished a little bit earlier, and it could do the next piece that's just coming off another machine, but you're not going to produce that because your work to list says you've got to do something else. So that could be one example. This could be another example. That could be another example of overprocessing. Just thought I'd throw that one in and make sure everybody's awake. But it's true with stuff like that, that if you're not using the right tools. And by the way, that was probably the slowest pit stop I've ever seen. If you look at Formula One right now, the Ferrari pit stop is about 2.2 seconds to change 4 wheels and tires. It's really cool. If you haven't seen it, just go to YouTube and Google, search for Ferrari pit stop, and you'll be amazed. There's about 21 people who all know what their job is, and if you blink, you miss it. It used to be 8 or 9 seconds, but it's down to 2.2. So it's really cool. So using the wrong set of tools, systems, or procedures is over-processing or inappropriate processing. The final waste is defects. Oh my gosh, defects. Frequent errors in paperwork, product quality problems, etc. Without defects, how would we ever get the practice we need? Incredible. But that's one, obviously, of the values that customers love. They love 100% quality, and that's really how we deem it as value. They want it right. And frequent errors in paperwork or product quality problems. I ordered 50 forks, not 50 stalks. Think back earlier on this week. How many defects have you come across, both in paperwork and product? And you probably see that there's quite a bit. There's quite a bit. So those are our 7 forms of waste. How do we remember them? How do we remember the 7 forms of waste? One of the things I like to do is Tim Wood. So if you look at this, Tim Wood, that will give you the 7 forms of waste. Transportation, inventory, motion, waiting, overproduction, overprocessing, and defects. So have an Eliminate Tim Wood campaign, and just hope that nobody called Tim Wood ever applies for a job. There's been a lot of Tims that I've met, and you're only half a waste, so that's not too bad. So let's look at this image. I think we can see Tim Wood in here. Transportation, I guess so. A lot of stuff you got to move out the way, got to transport it out the way, maybe to get to the orange stuff, or even to get to the switch box at the back on the wall. Unnecessary inventory, quite possibly. Motion that doesn't add value, absolutely. Waiting, oh my gosh, waiting all the while. Overproduction, producing more or sooner than the internal or external customer needs. I bet you've got a lot of stock in there that you've overproduced. Overprocessing, using the wrong set of systems, tools, or procedures, absolutely, definitely. And then obviously defects, and you could probably see that we've got a right here a defect. Okay, there's an actual defect in there, so that's really cool. Okay, all right, so let's just have a look at our next one. Oh, I got to get rid of my pen by the look of it. Okay, I need a little bit of help to get rid of this pen.
Richard, is there something on the side to
I've got it. I think I've done it. Okay. Perfect. Thank you. Thank you for your patience, everyone. You can see I'm not a webinar expert. So the first principle was define value from the customer perspective. The second principle is what we call identify the value stream. So it looks like I'm doing pausing. There we go. All right, we're good. We're good to go. So identify the value stream. So what do we mean by a value stream? Well, I got a nice picture here of a stream, and essentially it gives you the impression that something is flowing. So something flows. So a value stream, it must be value that's flowing. So what is a value stream? It's a sequence of activities required to design, produce, and provide a specific good or service, and along which information, materials, and worth flows. That's a really cool description of a value stream. So we're going to have a look now at a tool that is helpful to see the waste within your business. If any of you have ever done a lean simulation in a classroom, it's pretty easy to see the waste because you've got like a bird's eye view of what's going on within your factory using that simulation. And it's very easy to identify where the inventory builds up, where there's motion that doesn't add value, where there's waiting, where there's overproduction, where there's transportation. But in a large organization, you don't get a bird's eye view. You walk along the ground and you see points of interest, points of use as you walk around. So the way that we can see the waste in our businesses is by using value stream mapping. We use value stream mapping to give us as much information as we possibly can. So if you look at what's on the screen here, you'll see that we've got a lot of icons. We've got little pictures. And we say, you know, a picture's worth 1,000 words. And it is. And one little picture can tell you an awful lot of information. So a value stream map is especially useful for identifying potential waste spread over the course of an intricate process with an accurate definition of lead time serving as a crucial component. So let's have a look at how we construct a value stream map. So in this particular case, we've got a customer in the top right-hand corner, and then we have a supplier in the top left-hand corner, and along the top, from right to left, we have information flowing. Along the bottom, from left to right, we have the product flowing. So let's have a look how we construct a value stream map. We start off with our icon that shows an external resource, which is our customer, in the top right-hand corner. And we might put in, say, what the customer demand is. In this case, 1,000 widgets a day. We then put in the information flow, and we can see that we've got daily ordering, and it goes into order entry to production control, planning, materials. We also realize that we need some raw material. So we put the supplier in, another external resource, and electronically we're ordering purchase orders. We order purchases every week. Then we'll put the process in. What do we do to this once we receive material? And in this case, we stamp it, we press it, we weld it, assemble it, and we ship. And we're getting a lot of information already. Let's start filling it up a bit more. We know that we've got some inventory, so we count it, and we put underneath what the amount of inventory is underneath the triangle with the letter I in it. Then we've got some deliveries coming in from our supplier of raw material, and they come in once a week. And in this particular case, because the value stream map is just a snapshot at the moment that you do your value stream map, we see that there's 2 coils of material sitting there, and they're worth 3,000 pieces. We then put some more information in, and we find that we've got some data that we want to see. So I've got cycle time here of 1 second. I've got cycle time of 10 seconds, a cycle time of 20, and a cycle time of 45. On the stamping machine, I've got a changeover of an hour and a half. Then I've got a changeover of 30 minutes, 30 minutes, and 30 minutes. And then I've got some information for quality, and that's what yield means. For every 100 pieces, I only get 85% yield. 100% on the press, 90% on the weld, and 100 on assembly. So what I've got now, and let's add some more pieces on, is a weekly schedule that's adjusted every day. And they give the schedule to the stamp, the press, the weld, and assembly. What other information have I got? There's people who don't believe the data that's been put in MRP. So these little eyeglasses here, they actually mean go to scheduling. Go to scheduling. So basically, they're going to check every single day to see what's going on at each of the machines. And they adjust the schedule according to what's been produced. Well, we're missing something critical on a value stream map, and that is what we call the lead time, the lead time line. And what we do is we want to convert the cycle time into value added, and in this case, 1 second of cycle is 1 second of value added. In this case, 10 seconds is 10 seconds. And then we convert the inventory into time. So if you've got 3,000 pieces worth sitting here, and you're delivering 1,000 a day, then you've got 3 days worth of time sitting there. And the equivalent 1.5, 1.75, 2, and 2. When we add up the top line, it takes us 10.25 days to get through the factory. And on this poor little piece, we've added value for 76 seconds. 76 seconds over 10.75 days. Wow. Oh, wow. So what does that really tell us? It basically tells us that, let me go back one. Basically tells us that we're not adding value at the rate that we need to. And it goes back to essentially what we looked at earlier on, which was on a traditional non-lean production line, the value added content is very low, which was 5%. In this case, what you've got to do is calculate the ratio between 76 seconds and 10.25 days, and you'll see that it's far, far, far below 5%. So here's a value stream map. And the purpose of a value stream map is to see Tim Wood. That's all the purpose is. It's to see the waste within your organization. So let's have a look at the next poll question. So poll question 3, a value stream map is a tool to what? Is it A, enable managers to better understand their backlog, B, assist you in identifying or eliminating all forms of waste, C, assist managers to better understand their on-time delivery, or D, help you identify which workers are poor performers? Dave, could you bring up the poll question number 3, please? 20 seconds for everybody to click their button, and hopefully we'll get 100% correct. So is it A, is it B, is it C, or is it D? Okay, Dave, let's close that. And the answer is B, assist you in identifying and eliminating all forms of waste. Dave, let's see what the results were like. Oh, looks like we've got 100% right. So you all know the purpose of a value stream map. Thank you, Dave. Thank you. Okay, so a value stream map is a great tool, and essentially that is the second principle in the 5 principles of lean thinking, is to map your value stream, identify your value stream. Now, the third principle is what we call make the process flow. So we have our value stream map, and we've identified a lot of things on this value stream map. And one of the things that we might want to do in order to make this process flow is to create a cell. So that could be one of the things that we do. We want to create this cell so that they know what happens when they work with each other. The next thing we might want to do is to look at the deliveries of the raw material coming in, because we know that that's unnecessary inventory sitting in front of the stamp machine, because we ship 1,000 a day, but we only bring in the material once a week, which means that we've got to bring in at least 5 days worth of material at one time. So you could have more frequent deliveries. Obviously, we want to improve our quality. That's key. That's probably one of the first things that you might want to get your teams working on. Let's get that quality right, because that's exactly what the customer wants. They pay for 100% quality. We've got to give them 100% quality. And then balance the workload. Balance the workload. You could probably do that as well by reducing your changeovers. Your changeovers are incredibly high right now, and there are in fact some tools that will help you to reduce changeover time. One of them is called SMED, which is single minute exchange of die, and essentially it was brought together by the need to change the huge big dies in the automotive press shops that used to take 48 hours to change, and they set a goal of changing it within single-digit minutes. So less than 10 minutes to change the dies that used to take 48 hours. So when I challenge companies about reducing their changeovers from 90 minutes down to 10, they look at me as though I'm out to lunch, and they say it's impossible, until they do it. And then they realize that there's lots of ways of doing it. And as we go further in the webinar series, we'll share information on how to do that. So the third principle of lean thinking was make the process flow. The fourth is what we call pull from the customer. And the word pull, it sort of brings in our mind that two tug-of-war teams are pulling against each other. But if you think of pull from a different perspective, and let's say you go to your local supermarket weekly or monthly to buy goods, and hopefully you've got a list of what you need, and hopefully again your list is in the order that you walk around the store, like mine. You'll walk down an aisle, you'll look at what you need, and you'll pull it off the shelf. So you're pulling it off the shelf. Once you've pulled it off the shelf, there's a trigger there, a trigger that goes into the supermarket's process that says we need to replenish. And then they would go in the back shop and they would pull it out of stock and put it back on the shelf for the next customer who needs it. And then when they've pulled that out of stock, there's a trigger, a demand to replenish, and they would pull some more from the distribution warehouse and replenish the stock in the back of the supermarket. And then in the distribution warehouse, when a number of companies have ordered that stuff and pulled it, there'll be a trigger there to replenish, and they go back to the manufacturer and replenish that. And this is what we call a pull system, as opposed to a push system whereby MRP just says, go make this, I don't care what your next downstream customer needs. And that's a push system. So any MRP you've got, albeit that you think, oh, it's only making what's needed when it's needed, in fact it isn't. It's a push system. So we want to pull from the customer. Why? Because it's the customer that demands. And it doesn't necessarily mean the external customer. It could mean the internal customer. The internal customer is telling you what it needs. In one organization that I've worked with, they're in the printing business, and they print data-sensitive information like visa bills and gas bills, hydro bills. And they have a print section, and then they have what's called a folding and sorting and folding center that actually takes the printed material, and then they separate it and put it into the envelopes. Now, the customer of the print section is obviously the downstream sorting and insertion. So essentially, if the insertion people are full up, the printing people should stop. But in some cases, they didn't, because they were being measured on how much they could produce. And the result was that you got a lot of inventory that was overproduced, because it was produced sooner than what the internal customer needed, and it took up space. So pulling from the customer, once you've got a good process, is really very key. So in our value stream map, how would we do that? So here's our value stream map. We've made the process flow by putting in a cell and reducing some of the things. And now in this case, we've got essentially controlled inventory here. So I've got controlled inventory of 1,000 pieces, and I call this a supermarket. So this is a supermarket, and it's got a number of finished goods in here, just like a regular supermarket. And the schedule comes from planning. Shipping, you got to send 100 of these out. So they go and pull 100. And once it gets to 250 needed of this part, it sends a signal back to the cell here, and it says, make me another 250 to replenish over here. And in order to do that, they send a signal and take out the necessary material from this supermarket, and they bring it in, and then they transform it and replenish. And the same happens all the way upstream, and now you are getting a really good pull system happening based on customer demand. Oh, and guess what? We've also got our 10 1/4 days down to 4 1/4 days. We've reduced our value added time a little bit, but in reality we haven't, because these two are still taking 45, this one's still taking 20, this one's still taking 10. So you still really got 75 seconds in here, but because every 45 seconds one piece is finished, it's 45 seconds of value added, which is quite interesting. So if we now look at pull from the customer, we can see that we've got a really good process going. So let's have a look at our next principle of lean thinking, and it's the final one: head towards perfection. And you never stop thinking about continuous improvement. So in this case, what we've done is we've actually decreased our changeover time again. We've improved our quality even more, reduced our changeover, we've reduced our safety inventory a little bit more, and we've reduced our batch size now to 150. We've also redeployed one of the team into another cell to help them lean it out as well. So we've took another virtual half a day out of our lead time, and we've actually reduced the cycle time as well, because we've got 3 people and we've balanced the workload a little bit more. So we're continuously improving all the while, which is absolutely fantastic. So the 5 principles of lean thinking is essentially value for the customer, identify your value stream, make your process flow, pull from the customer, and then head towards perfection. So let's have poll question number 4. See if you can get this one. Which of the following is typically correct? So GT equals greater than, LT equals less than. So your lead time is less than your cycle time and is less than your value added time? Or is it B, lead time equals cycle time and is less than value added time? C, lead time is greater than cycle time and is greater than value added time? Or D, cycle time equals value added and is greater than lead time? So Dave, can we bring up the poll question? So here we go. 20 seconds, team. Let's hope you all get the right answer. This one's a little bit more difficult, but it's pretty logical, and we'll explain a little bit why. Just another few seconds. Hopefully you've all got your answers in. Okay, Dave, let's go back to the slideshow. All right, so the answer to this one is lead time is greater than cycle time, which is greater than value added. So your value added is always your smallest time. We saw that in all the rest of the information that I've given you today. Cycle time, in fact, in the value stream map, we did use it as value added, but if you look at actual cycle time, there is some hidden non-value added time inside cycle. So cycle time is always a little bit greater than value added, and lead time is the longest. So Dave, let's look at the results and see how we did.
So Richard, we have 86% on C and 14% on D.
Okay, and I can see why we had 14% on D, because in the value stream map example that I gave you, the cycle time did in fact equal the value added time, but it wasn't greater than the lead time. So I could see why a couple of you may have got that wrong. Okay, Dave, let's go back. All right, thank you. So that's really good. We're keeping you on your toes. So after working on your current state map, is there anything else we need to understand to see if our process is capable of meeting customer requirements? So we need to understand the rate of customer demand associated with our process. And for this, we need to know about what we call takt time. So takt is the German word for rhythm or beat. In this particular case, this is an image from the early 1940s at Boeing. This is the B-17 wing assembly area. And if you notice in the top of the screen, we've got a big, huge clock here. This big, huge clock is what they call the takt clock, and they used it to pace themselves as they were producing things during the day. Okay, so essentially takt time is the rhythm or beat of something. So it's the rate at which the customer demands his product. So what's the formula we use? So takt time is your available working time divided by customer demand. So working to takt synchronizes the pace of work with our customer demand. Let's have a look at an example. So 480 minutes is what the attended time per shift is. We've got 3 10-minute breaks. Yeah, I'm not very good. I don't give them lunch. So the total working time per shift is 450. Number of shifts is 3. Total available time a day is 1,350. And my customer demand is 50 units a day. What's my takt time? So there's my formula. And before you all get your super smartphones out, you can do it pretty simple. Cross off the zeros. 5 into 13 goes 2. Carry 3. 5 into 35 goes 7. If I've done it right. 27 minutes is your takt time. So, poll question number 5. The takt time number means what? Note that GT is equal to greater than. So, takt time number means assembly time must be greater than or equal to takt, never less. Takt time means the pace of manufacturing, less downtime and scrap rate. Takt time means a part must be made every X seconds to meet customer demand. Or D, time to make a part less the lead time and the available working time. Okay, Dave, let's bring up the poll question and see how many we get this one right. So is it A? Is it B? Is it C? Or is it D? This one's a little bit more difficult. Okay, Dave, let's have a look. We'll see what the answer is. So the answer is C. A part must be made every X number of seconds to meet customer demand. Let's see how we did with the poll, Dave. Awesome. Love it. Everybody knows what takt time is. What's the purpose of takt? Well, there's a lot of purposes for it, because essentially it's telling you that you're either on schedule, ahead of schedule, or behind schedule. And takt time can vary, and it will vary according to customer demand, and you might have to put additional or pull out resources in order to match your line with the customer demand takt. Okay, Dave, let's go back. Thank you. All right, so we've created a current state value stream map, And there's questions that we will ask in order to get to a future state. So we want to know what the takt time is, because that's critical in understanding if we've got enough people or we've got enough capacity. So for instance, if you've got a takt time of 25 minutes, and one of your operations to make your product is 60 minutes, that tells you something straight away. So if it takes you 60 minutes to make one piece and your takt time is 25, it means you've actually got to put 2.x number of machines in there in order to produce the takt. Straight away, it's helping you determine capacity and resources. Number two, will we build to shipping or to a supermarket? So in our value stream map, we actually had some supermarkets. And we put supermarkets in for a particular reason. Number three, where can we use continuous flow? Well, can we make one piece at a time and then pass it on to another operation and do the next piece of work on it and then pass that on and do the next piece of work? So we're not doing them in batches, we're actually doing one at a time. Where do we have to use supermarket pull systems? And the simple answer is where you cannot continuously flow. If, for instance, you have to make some product and you don't have the processing capability to either heat treat it or do some special process to it, and you have to send it outside to an outside resource, and you're making one piece at a time, then you would feed those pieces into a supermarket, and then whatever the batch size the outside company would need in order to give you a good product and cost-effective cost per piece, you would send that batch out, and then obviously you would put it into a supermarket after you receive it, and then you start to pull out one at a time again. So the other questions we can ask: at what single point in the chain do we trigger production? We need to know that, and usually it's closest to the customer, might be to the pacemaker. How do we level mix? So you might be looking at hijunka, which is a term that you're probably not familiar with, but it talks about level loading. And then what increment of work will we release and take away at the pacemaker process? And the pacemaker, in most times, is your bottleneck operation. And then finally, what process improvements will be necessary to achieve your future state? These 8 questions actually are derived from the book Learning to See. So Learning to See is all about learning to see the waste, and it's written by John Shook and Mike Rother many, many years ago. It's actually one of the books that is the reference material for the Lean Bronze certification exam. It's a really great book. If you haven't read it, it will help you understand how to do value stream mapping and how to go from your current state to your future state. So let's recap. Here's our 7 forms of waste. This is how we remember them. Tim Wood. So have an Eliminate Tim Wood campaign. Here's your 5 principles of lean thinking. Define value from the customer perspective. Identify the value stream. Make the process flow. Pull from the customer and head towards perfection. So that's what we've learned today. But let's look at a big picture. How do we understand the big picture? I'll give you a quick scenario. I've got a welding machine that can produce 10 pieces per hour, and each piece is worth $100. So if I go and give you $500 and say you could double the output to 20 pieces per hour, would you take it? Would you go do it? And if that's all you knew, you'd probably say yes. But if you look at the production line, you'll see that operation 5 can only do 10 pieces an hour. So by changing up 3 to 20 pieces an hour, it wouldn't be worth it, because you'd still be piling up in front of up 5. So where would you spend your money? Well, you might say, I'm going to go to up 3 and make it 15. I'm going to go up 5 and make it 15. Then at least I've got the ability to do 15 pieces an hour. But you might not have sales, because your sales are only 8 pieces an hour, and they fall right into your capacity right now. So when you look at point improvements, it may not necessarily be the right thing for your value stream or your production line, because you might be increasing the utilization, but at the end of the day, you'll be generating waste. So look at the big picture. Before we leave, there's one final thing that I want to leave you with, and that's material and cash flow. Many organizations, the people who add the value, they don't understand this, but it's really significant, because lean is an incredible way of managing cash flow better. And we've got a situation here where we've got a supplier who actually takes 28 days to deliver material to us. We then take 22 days to make it, 2 days to ship. We get paid in 60 days, and our supplier we pay in 70, but we're in a negative cash flow of 14 days. So the lean team decides to improve the lead time, because the lead time is huge, and you can make a great advancement if you can get this down tremendously. So we take all the waste out and we make it 2 days. Okay, looks like I've got to get rid of this normal drawing mode. There we go. So we make it 2 days, and what has that done to us? We haven't changed the lead time from the supplier. We haven't changed the terms, but we're in a positive cash flow. And now we make this 1 day, and essentially we're going to try and reduce this. And if we can reduce this down to a really good number, then maybe our customer won't have to carry stock, and we can improve the terms. And here's the net effect. We've got this to 1. We've cut this by 1/4. We've said don't have to carry inventory. We're down to exactly now 30 days payment terms. We've relieved our supplier and paid them 25 days less, and we're still in a positive cash flow. So that's what lean can do as far as cash flow for you. Back in 1924, Henry Ford turned iron ore into cash in 41 hours. 13 hours floating down the Rouge River was non-value added. 1943, 17 B-17 bombers built every day. Wow. Once upon a time when we were lean, we built 17 aircraft a day, and over the past decade, Boeing has put out a number of videos to say, let's go do it again. This was how they did it, and it works. This was their production that they predicted. This is what they got to. So remember, how do we define lean or continuous improvement? Continuously eliminating waste, so every step has value for your customer. So just go do it. Thank you, everyone.
Thank you, Richard. We've got time for maybe 1 or 2 questions. So if you have any questions, please submit them on the right side of your screen, and we'll see if we can answer them quickly for you. If not, enter them anyway, and I will forward them to Richard, and he will send them to you, or I'll send them by email next week.
Okay, so while they're actually doing that, let me just remind everyone one thing before we go, that the next webinar is Thursday, November the 3rd at 1 p.m. Eastern, and it's part 2, Make the Process Flow. We're going to give you an introductory webinar on 5S. If you don't know what it's about now, you certainly will when we get to it. So, any questions, Dave, before we close down? I think we've got 1.5 minutes, 2 minutes left.
Yeah, one quick question here, Richard. How do you define value in an office environment? Because we don't change the form, fit, and function of a product when we create information.
Oh, that's a great question. If you look at value-added content in manufacturing, it's essentially when you're changing the form, fit, or function of the product. In an office, what we do is we say that we classify value-added as touch time. So it's touch time. Basically, if you have all the necessary information, documents, everything you need, how long does it take you to actually perform the tasks that you've got to complete? So obviously compiling all the information, gathering it, that's like setup, which is non-value added, or changeover, which is non-value added, but actually doing the work or the task that you need to do, like filling a form out, like entering data into a computer system, and that's what we call touch time, and that's what we call value added, Dave.
Thank you, Richard, for a very insightful presentation. This brings our webinar to a close. As Richard mentioned, our next one in this series will be Thursday, November 3rd, titled Make Your Process Flow with Richard Evans. Please don't forget to fill out the short survey that'll be in your inbox. Thank you, everyone, for attending, and have a productive day.
Thank you.